Views and news with Clarence Ford.
Share your perspective.
Only on Cape Talk.
It's very nearly 9:30, and that's a very important appointment that we have with the doctor. And we're talking about the naked scientist, Dr. Chris Smith, a lecturer at the University of Cambridge, joins us 9:30 every Friday, just after that news headlines. If there's that question that keeps you up at night, well, he's going to answer it. Welcome, Dr. Chris Smith. Great to have you back.
Hello, Clarence. How are you?
I'm good, thank you. I'm really good. We've got some great sunshine, but winter returns this weekend. Clearly, spring is in the air.
Well, we did have summer this year. It was about a day long. It was lovely.
A day or two?
Yeah, it's gone now. So back to normal. But there we are. But what else has been happening on your side of the continents?
Well, lots of exciting stuff on the political front all over the continent. I think that's been dominating everything.
Well, I thought you might highlight the question with monkeypox, of course, because this has been a huge story around the world.
Let's start there because that's a question in then.
Well, the World Health Organization last week said we're declaring a public health emergency of international concern. Now, that's not the same as saying we are declaring a pandemic. What they're saying is this is one step down from a pandemic. This is saying everyone needs to be on their guard because things are on the move. Now, what they're referring to is the problem in chiefly the Democratic Republic of the Congo, where for the last about 9 months or so, they've seen a steady increase and now a really big surge in the numbers of cases of an alternative, what we call clade or variant of the normal form of monkeypox or mpox that circulates in that geography. It's a clade called clade 1b, which is a spin-off of clade 1, which we normally associate with that part of Africa. And unlike the outbreak we saw a couple of years ago, which was chiefly centred on one particular community, that was the gay male community, this is far more wide-reaching. It's spreading among sexual networks, yes, but also household contacts. There are children who are being affected as well. So the disease appears to be more infectious and possibly more transmissible in that respect, but far more diverse in terms of who's being taken down, and the numbers are very high. And this is what has provoked the World Health Organization to express their alarm. We've also seen Europe, Sweden specifically in the last week, declare a pickup of a case. That was a returning traveller, so they don't think they've got an outbreak in Sweden. They think that they have had a case come back via international travel routes, which shows the system's working because the alert's gone out, people are scrutinising people, taking careful travel histories and so on, and they've picked up a case. But this puts us on our guard that we may see more international cases. There is the potential for spread internationally, and therefore we have to be more prepared. And therefore countries across the world, as well as especially in the African continent and those countries neighbouring the Democratic Republic of the Congo, where cases have been picked up, which is Burundi, Kenya, Uganda, Rwanda, those sort of neighbouring nations, they have also seen a bit of spillover across their borders, so they're also on alert. So this means things like public health initiatives. It means making sure there's a plan in place for if cases are picked up in any country. It means putting people on watch for vaccines and vaccine readiness, and also reinvigorating international research efforts, because I've been speaking this week to quite a few experts who work on pox viruses and that family of agents, and when I ask them questions about the biology of these viruses, they're repeatedly saying to me, well, we don't know, Chris. This has not been studied yet, and this is why we need more research to be done. And so they're all putting in bids for research funding in a number of different initiatives in order to start to study this phenomenon and come up with better ways to manage the outbreak.
I think since it's such a significant outbreak, let's understand how we contract it and what the prognosis is.
Well, it's a member of the same family of viruses that caused the dreaded smallpox, the human exclusive infection that was luckily eradicated decades ago now. And what we were doing about smallpox was vaccinating people with a vaccine called Vaccinia, which is a related member of that family, and it's so similar to smallpox that it was capable of protecting people secondarily against smallpox, but without causing disease in those people. Turns out it can also prevent monkeypox. So we're using the same vaccine now to protect people against monkeypox as we were using to protect them against smallpox. But why I'm going over this ground is that the reason we're seeing these outbreaks now is that where hitherto we were vaccinating the world population against smallpox to stamp it out, those people are now older people And as a result of that, some of them are dying off. And so the number of vaccinated people in the population has dwindled. And we've reached a tipping point where the number of susceptible people to the infection in the population has now become sufficiently high. And that, coupled with the other factors that are playing a role, and this is answering your question, which are close association with close personal contact between individuals, high population density. The countries that are being affected chiefly are very, very densely populated centres in those countries, cities, and also people who are living in more deprived settings where you tend to see a facilitation of disease transmission and a more mobile world population. All these factors are conspiring together to make these outbreaks more dramatic. When you catch the infection after an incubation period of up to a couple of weeks, you tend to get a febrile illness. People become prostrated, they feel very unwell, their glands swell up, they may have a thumping headache, and then you get this very characteristic rash, which starts on the face and then spreads down across the body. And this is the blistering pox rash that is so characteristic of this family of diseases. And those blisters, they appear to be blisters, but they're full of sort of solid material. They're crammed with infectious virus. And so if you have close contact with those lesions and it gets through a breach in your own skin, into your eyes, respiratory tract, or sexually, you can contract the virus, and then that cycle repeats itself.
And the prognosis, Doc?
Well, this is the interesting thing that we've always said. This Central African form has a high mortality rate of maybe as high as 10%, whereas the West African form, which we saw cause a problem 2 years ago, has a much lower mortality rate, under 1%. But in recent trials that they've done, and some were announced a couple of weeks ago, they found that their mortality rate was actually quite a bit lower. And in the people that went into the trial, it was even lower still. It was around about 2 or 3%. Now, what that tells us is that a lot of the mortality associated with this is probably because people are in poorer health to start with and living in a greater state of deprivation. So if we improve our supportive care for people, and this is the mainstay of management, once a person's manifesting the disease, we don't actually have anything at the moment we can do therapeutically other than offer best supportive management we can and help the person's own immune system to get them better. But if we do that, it shows we can actually improve the prognosis enormously. But the mortality rate can be up to 10% in some case series for this, which is why they're very worried about it.
Okay, so this is South Africa specifically, and according to the World Health Organization, the last case of smallpox in South Africa was reported in 1972, and smallpox vaccination stopped shortly after the global eradication of the disease in 1980. Thus, any immunity from prior smallpox vaccination, which is cross-protective for mpox, will at best now only be present in some persons over the age of 44 years. Does that mean that I've had the vaccine and I'm immune?
If you've been vaccinated, Clarence, you're very lucky. You are immune because these viruses tend to provoke very long-term, if not lifelong, immunity. And if you have some other problem with your immunity later, if you have to have an organ transplant and end up immunosuppressed, if a person catches HIV and that damages their immune system and it's not treated, this can make them vulnerable. This can obviously erode that protection, but people who have been smallpox vaccinated or have been unlucky enough to run into monkeypox and caught that, in the aftermath, off the back of your recovery, you're then immune for life. But as you say, most people now under the age of 40 are not immune, and that number of people are the people who tend to be the best networked in society. They're the most mobile, they're going out to work, they're also socialising, partying, they are participating in these sexual networks that are also transmitting the infection, and that is why, or at least part of the reason why, we're seeing this uptick now.
Okay, well, information is the best weapon. You want to arm yourself, and I think that was really worth your while kind of information, courtesy of the Naked Scientist. Let's take a listen, Joe. We'll go to the WhatsApp line.
Good morning, Clarence and Dr. Chris Smith. Whatever ever happened to that scientist that got shot with an atom? I read something that he put his head in one of those machines and the atom went through him. What actually happens when that actually happens? I'm just curious. And thank you. That's Jason here from Brackenfell.
It sounds like the Incredible Hulk or Spock in Star Trek when he goes into the reactor room in the Enterprise and fixes the Enterprise engine and gets them away from the explosion that's about to wreak havoc in that patch of the universe. I'm not familiar with the story of someone putting themselves in the path of an atom, but this is happening all the time, remember. You being bombarded by atoms and molecules from the room around you all the time. Billions of them are hitting our skin all the time, and there are millions of cosmic rays pouring into our patch of the Earth's surface from space at very high energy, some of them, all the time. And there are millions of neutrinos and other kind of particles streaming through us all the time. Thankfully, most of these things do not do any harm because they whiz through, and to them we're pretty invisible. It's like a transparent pane of glass and they go flying straight through. The odd one will interact with our DNA, and this has the chance to damage our DNA, which is why over time we accrue damage to our DNA and we may develop cancer. And that's part of the aging process. If you go into space, and those two astronauts who are stuck up there in space for much longer than they'd like, well, I don't know, they say they're enjoying themselves actually, but their 8-day space journey may have turned into an 8-month stay in space. They're going to be seeing a lot more cosmic radiation than they otherwise would have done, and this is going to have an aging effect on their body. So it's not just a scientist running into an atom, it's the fact that we are continuously being bombarded by high-energy particles which have the potential to damage our DNA, and that puts us on the path down towards cancer in the long term. It's certainly part of the aging process. And if you live in parts of the world where the rocks are more radioactive, then it also increases your risk of cancer for exactly the same reason.
Dr. Smith, why can't I walk through a wall and not hurt myself if atoms are mostly empty space?
Well, the reason is that although atoms are essentially empty space, an atom comprises a very small nucleus, which is the positive charge, and this is surrounded by a cloud of electrons, which are the negative charge. And this was the insight that Ernest Rutherford produced with his work at Cambridge University over 100 years ago, when they were firing alpha particles, which are the nucleus of a helium atom and are positively charged, at a thin sheet of gold. Now, before Rutherford did these experiments, everyone thought that an atom consisted of a blob. They called it the plum pudding model, where there was a sort of blob of charge and they had opposite charges peppered throughout it, which gave you this sort of homogeneous area that was the atom. And what Rutherford saw was that some of the alpha nuclei, the alpha particles, came flying back at him when he fired them at the piece of gold. Now, the only way that could happen is if all the positive charge in an atom was concentrated in one tiny area and most of it was empty space. So that told us that was the structure of an atom: concentrated charge of positive at the centre and a cloud of electrons which are negative round the outside. But therein is how it all works, because if you bring one atom, which is a cloud of negative charge around a positive centre, close to another atom, the negatives are going to repel each other as they get closer and closer together. And you'll get to a point where you cannot push the electron clouds any closer together because the repulsion of like charges becomes so great it pushes them apart. And so when we're standing on the floor, the atoms in our shoes are being pulled towards the centre of the earth by gravity, but the atoms in the floor are seeing the negative charges around the atoms in the soles of our feet, and the two begin to repel. So we're resting and bobbing around effectively on an electrostatic field.
Right. I hope that answers that question. I won't suggest that you kind of walk through the wall, though. Joshua writes, Chris, if X-rays are harmful to humans, how come microwaves, 5G and other forms of radiation are not? That's, Josh, yeah, in Lakeside.
Hi, Josh. Very insightful question. And the answer is it all comes down to energy. These forms of radiation are all on a long spectrum, and they range from very long wavelengths, so a big distance between the peak and trough of a wave at one end of that spectrum, to very, very small waves with a very short distance between the peak and the trough at the other end of the spectrum. And as you go through that spectrum, the waves become more and more energetic. They are packing a bigger and bigger punch. And at the long wavelength end of the spectrum, where you have microwaves and radio waves, they are not jiggling around hard enough to do damage to our cells and tissues and DNA. Once you get towards visible light and the violet, the ultraviolet end of the spectrum, you begin to have energies there which are called ionizing. And they are sufficiently powerful that they will go into your cells and they will potentially damage your DNA, because the energy that they're imparting to the DNA is capable of shaking the molecules around hard enough to break them or cause reconfiguration of their structure. And once you go beyond ultraviolet, you're getting more and more energetic X-rays and then gamma rays. The amount of energy there is so high, you can literally tear your DNA to shreds. And this is why we actually use this as a way of sterilizing food. And there's a great story going back decades now, but the Americans were making corned beef. Remember bully beef, the stuff that we would put in a tin and it would have a really long shelf life. And they were irradiating the meat by zapping it with gamma rays. And this tears to pieces the genetic material of life so that it destroys microorganisms. And that's why there's nothing left in there to break your meat down, so it has a long shelf life. But then someone discovered that there are actually bacteria that can survive this. And the bacterium called Deinococcus radiodurans was discovered. And these are the most radio-resistant, amazing forms of life you're ever going to see. They were surviving levels of gamma irradiation that no one ever thought anything could survive. And in fact, we now know how they do it because they've got multiple copies of their genetic material, and they have a special mechanism which, when their DNA gets busted to pieces by irradiation like this, they can rebuild a working copy from all the fragments of the other bits of their genome. So, yeah, steer clear of radiation if you can, but you're all right as long as it's not ionizing radiation, which is where ultraviolet starts on that scale.
What are the benefits we hope to derive from the Large Hadron Accelerator? What's the worst case scenario that can happen?
Well, the benefits of this $3 billion machine, which actually has now gone through multiple upgrades to give it more and more energy, are that with one of the largest machines in the world, which this is, you can examine the structure and behaviour of some of the smallest entities in the universe. And it's paradoxical, isn't it? You need a bigger and bigger machine to study things that get smaller and smaller and smaller. But what it's done for us in the last decade or so is to enable us to probe the structure of the atomic model. And we now have an understanding of how things have mass, thanks to the discovery of the Higgs boson, for example. Peter Higgs, who died earlier this year, actually, just a couple of months ago, he postulated the existence of the Higgs boson. The idea behind that being that there is a field that pervades the universe, and this field interacts with the atomic structures and subatomic particles that make up the matter in the universe, and it endows them with mass. Why, when you put a kilo weight on the scales, it registers, I weigh something. That's down to the Higgs field. So we've been able to do that. We've been able to understand a lot more about the other subatomic particles. So it's very useful for probing our understanding of physics and therefore our understanding of how the universe works, how the universe is likely to evolve, and other hard to answer questions like dark matter, for example. The risks of this are that we spend a lot of money and we don't make the discoveries we're hoping to make. But in terms of, are we going to destroy the planet with the Large Hadron Collider? No, there's not really any chance of that happening, because as physicists argued, the energies of the particles which are being created in the Large Hadron Collider are actually lower than the energies of particles raining in from space and hitting the Earth all the time anyway. So we're not doing anything on Earth with the particle accelerators that we've built that are not happening naturally already and in much greater abundance, just naturally via what's out there in space. So we don't regard this as a major risk and a threat to the world.
Okay, well, Richard and Al most certainly are going to sleep a lot more pleasantly from here on in. That question answered. And then there's this one in from Katlejo. Dear Chris, people and other doctors say that drinking vitamin C every time you have symptoms or sick weakens the ability for your body to fight infections on its own because you're always boosting the vitamin C. Is this true? What is the disadvantage of vitamin C?
Vitamin C is one of our antioxidant water-soluble vitamins, and you get it from fresh, chiefly fruits, but pretty much anything that's a vegetable. And if you're a big cat, you don't need to eat any grass and vegetables, because you can also pick up vitamin C from the animal meat that you eat, because animals have vitamin C in them, so you can get it that way. So what does it do in our body? It's an antioxidant. It's absolutely essential for helping us to build collagen, one of our connective tissues, because it's used to provide the way in which we chemically link together the proline particles which are in the amino acids of our collagen. And if you don't have enough vitamin C, you will get the problem called scurvy, which first became manifest when people went to sea for long sea journeys and didn't have enough fresh fruit and vegetables, and they got awful skin problems. That was a manifestation of scurvy. And the reason we get called limeys is because they realised that if you pack citrus fruit into the ship's holds, they will survive for a nice long time, but they're a rich source of vitamin C, and this will help people to stay healthy on long sea journeys. Hence, they got the name limeys, because they were using limes and lemons and things on their sea journeys to stave off scurvy. There's not really any evidence that if you take too much vitamin C, it's going to do much for your immune system. There's some studies showing that if you boost your vitamin C, you can reduce your risk of getting infections if you take severe exercise, but that's one study. And because it's water soluble, if you eat too much vitamin C, all that you do is produce vitamin C rich urine, which is very nice for your urine and very nice for the bacteria in your urine, because they won't have to worry about oxidative stress so much, but it's not going to really help you. So vitamin C, eat a healthy diet. Your body's evolved to get the right amount from what you eat. So as long as you eat plenty of fresh fruit and vegetables, you don't need to waste money on vitamin pills. And there's not much evidence that taking mega doses of vitamin C really help you in any way in the long run. Or if you do take mega doses of vitamin C, you somehow erode your immune system, because, as I say, you just turn the excess into very expensive vitamin C rich urine.
And limey is not an abbreviation. There you have it, okay? We had one in, and I want to end off with that one. What on the social media streets is that mpox is now transmissible via the air, i.e. coughing. Is that true, Christopher?
Well, there have been cases in family settings. But to be honest with you, this probably is a reflection on the fact there's close personal contact between members of a household unit. So it might be that if a person was really highly infectious and you got really, really close to them, and lots of that material coming from the blisters was getting onto you and into your eyes, for example, that might be a route of transmission. But really, chiefly, the main way by which this spreads is close contact, skin-to-skin contact, so kissing contact, cuddling contact, sexual contact, rather than as an airborne virus. So we're more worried about the former than the latter.
Big thank you, Dr. Chris Smith, lecturer at the University of Cambridge. It is nearly time for news. It comes your way at the top of the hour.